The title of our lab is Activity 69, Solar Heating.
Our question is, what is the efficiency of a solar energy collector?
Our hypothesis is that the efficiency will be more than 20% because the black wires will absorb the heat, which will make the molecules of water speed up and become hotter. The materials we used are white plastic tube holder,
Styrofoam cup,
Water pump,
thermometer,
1.5 volt battery,
150 milliliter graduated cylinder,
black tubing, wire leads with clips, one red, one black.
battery holder.
timer.
This is our procedure.
Angle the white plastic tube holder so that it faces the sun. Attach one end of the plastic tubing in the pump. Put the pump in the foam cup. Pour 150 milliliters of water in the pump. And put the other end of the pump in the plastic tubing. Put the thermometer in the cup and record the starting temperature on data table 1. Put the red wire on the positive terminal of the pump. Repeat step 8 for the black wire. Attach both wires on the battery holder. Record the temperature every minute for 15 minutes on data table 1. Start the timer when you are ready, and repeat steps 1 through 12 for two more trials. Alright, that's it.
Whoa, it's Bill Nye!
The energy transfer in this lab is from the sun to the black tubing to the water to the pump and the battery. The energy transformation in this lab is nuclear to solar to thermal energy to CP to CPE to sound. In this lab, we use a black tube to transform the thermal energy to the water. Since black absorbs heat, the black tube was able to heat the water. This made the temperature of the water increase. The pump is connected to a battery through a series circuit. This is not good because if you don't plug in the series circuits the right way, it will not work. Conduction in this lab is energy from the black tubing to the water. Conduction is the transfer of energy by touching.
Trial 1, the starting temperature was 22, the average was 28, and our temperature change was 10 degrees Celsius. Okay, for trial 2, our average temperature was 19, our change was 2, and our starting temperature was 17 degrees Celsius. For trial 3, the starting temperature was 15, the average temperature was 19, and the temperature change was 5. For trial 1, the energy transfer was 1500, and the efficiency was 24%. For trial 2, the energy transfer was 300, and the efficiency was 5%. For trial 3, the energy transfer was 750, and the efficiency was 12%. For the first step, you're gonna need to multiply the temperature change to the milliliters of the water. Then for the second step, you're gonna need to find the circumference of the area you used to put in the tube holder, to put in the black tubing in the tube holder. And then for the third step, you're gonna need to find the energy transferred, which is 1.5 times 283, which is the circumference of the white tube holder, times 15, which is the minutes. And then for the fourth step, you're going to need to divide calories transferred to the water, which is your first step, to calories of the tubing, which is your third step. And then you're going to get a decimal, so you're going to need to multiply it by 100 at the end to find out the percentage.
These are the efficiencies of our data. Trial 1, efficiency was 24. trial 2, the efficiency was 5, and trial 3, the efficiency was 12.
In this lab, we wanted to find out what is the efficiency of a solar energy collector. Our hypothesis is that the efficiency will be more than 20%, and the black tubing will make the molecules speed up. This will make the water temperature increase. The average efficiency of all 3 trials was 14%.
Efficiency is when an input is created to make less energy being used. It is low because not all of the energy is conducted into the water. Also because of the time of day and the angle of the sun. The data we collected does not support our hypothesis because the average efficiency was 14%.
In this lab, we learned that the angle of the sun was very important. When the sun angle was more direct, the temperatures increased. When there was less direct sunlight, the temperatures did not increase. We also learned that you would have to plug the clips correctly. Since it is a series circuit, it only has one path, so if you would unplug it, it would not work.
We learned that silver energy collector is not a reliable source. However, it is renewable and does not cause pollution. The results that we got was different the first day than the second day because of the sun angle. The first day we collected data in the afternoon, so there was more direct sunlight. This made the temperature of the water increase. The second day we collected the data in the morning, when there was less direct sunlight. This made the temperature increase very slowly. The system that we're dealing with, people can use with their pools. This will allow them to be able to limit their pool time in the winter. Even though in the winter there's less direct sunlight, it can still heat the pool a little bit. People using this system should find a thicker black tubing and a bigger pump to generate the water. Since the black tubing absorbs heat, then it would heat water more. When it is summer, then it would be more efficient. In the winter, it would be less efficient. If we were to do this lab again, we would have thicker black tubing. We would also change the color of the tubes. We could also have a bigger pump, and we also wanted to do trials in different angles of the sun. If we were to do the lab again, we will have a larger collector for more surface area, and we will want to do the experiment at the same time of day.